Dear students, welcome back. Now in this session we are going to do assignment number 11. As usual, the first few assignments, which is in this case up to 7 number, will be done in your tutorial sessions. We will start doing the problems from number 8. Okay, so what we are given is a solution. We are given a solution of this ODE, okay, on any interval on the real line. We need to find its general solutions, which means we are given an ODE, we are given one of its solution, we have to find its general solution. In this case, since it's second order ODE, since one of the solution is given, if we find a linearly independent solution corresponding to the given solution, then the span of that will be the general solution because it's the second order ODE. Okay, so let's do that. So first of all, we need to show that the given function is a solution to the ODE. Okay, so sine x over root x is a solution to the ODE. So to do that, let's start from here. Okay, so what we are given, what is happening? What we are given is what's happening, man? Yeah, sine x over root x is given to you. Call this as your y of x. Let's say we need to show that this y satisfies y square double prime plus xy prime plus x square minus 1 by 4 y equal to 0 in some interval of positive real line. So it's easy to verify, quick to verify. So x square 1 over 4 sine x by root x, then plus x times y prime, right? And y prime is precisely sine x over root x, so cos x over root x and sine x to x 3 by 2. Okay, so, and that's your xy prime, and plus x square of y double prime. So x square of y double prime, so differentiate this once more, so you should get minus sine x over root x minus cos x over x 3 by 2 plus 3 sine x by 4 x 5 by 2. Okay, and this has to be 0. Okay, so you see here that the first term here cancels with the first term here. Okay, and yeah, so there is an x cos root 2 is x squared, so this is 1, this is 1.5, this is 2, right? So that should be there should be a cancellation. X power half plus 1, so x will go away, so x times, so this term here and this term here goes off. Okay, and then we should have 0. So what else is remaining? What else is remaining is 1 by 4 sine. So there is a 2, there's an x square here. So 5 by 2 minus 5 by 2 minus 2, it's square root of x. So square root of x, so this will become sine x by square root of x. And this again 3 by 2 minus 1 will be, this is again square root of x. Okay, so what we have is minus 1 by 4 sine x square root of x minus 1 by 2 sine x square root of x plus 3 by 4 sine x square root of x. Okay, now this is half minus quarter is minus 3/4, so that's okay. Okay, so that satisfies the, so this is a solution to this ODE. Now what we need to find is a general solution, which means we need to find a linearly independent solution. Okay, so for that we know this techniques, that we introduce another function u2 of x, which is vx multiplied by the given solution, which is sine x over root x. Okay, and if we use this, so we want u2 to be a solution to this ODE here, which means it has to satisfy this ODE. Okay, so you differentiate u2 once, you will get something. I'm not going to do that, please go ahead and do it, it's product rule. You will have something in terms of v. Similarly, go ahead and differentiate it twice, you will get something. Okay, in that, if you use this information that that the sine x over root x is already a solution to that ODE, then we will get the relation sine x v double prime plus 2 cos x v prime equal to 0. Okay, and so that's going to give you v double prime v prime minus 2 cos x sin x, right? So that's v double prime v prime minus 2 cot x, right? So if you integrate them, solve for v, right? So you should get v is minus cot x. Okay, and if v is minus cot x, then u2 of x is minus cos x by square root of x, right? Because cot x is cos x by sin x is cos x by root x. Okay, so which means that your general solution is the linear combination of linear combination of the sin x root x and this, so which means alpha times sin x plus beta times cos x by root x. Okay, so that is your general solution to this problem. Okay, fine. So we have solved problem number 8. Now let's do problem number 9. Now what is problem number 9? Problem number 9 is asking you to find the general solution of the following ODEs. So they are linear, homogeneous, and they are constant coefficient ODE. Okay. So let's do 9A. So let's do 9A. So if you look at the given equation, it's y double prime minus 2y prime something. Okay, so it's y double prime plus 2y prime. I think that's a typo here. This should be single prime, not double prime. 2y prime. Okay, 2y prime plus omega square plus 1 y equal to 0, where omega is some real number. Okay, so now what is the corresponding characteristic equation to this constant coefficient ODE, which is precisely m square plus 2m plus omega square plus 1, and that's equal to 0. Now this is a quadratic equation, so you can find the roots of this. So if you use the quadratic equation formula, formula for the roots, so you get m is equal to the complex roots I times omega. So these are the roots. So now the solution depends on what omega is. Suppose omega is 0, then you have the repeated roots. M is minus 1, 1. Right? Minus 1 is repeated root. So corresponding to that, you will have the general solution, which is corresponding to the repeated roots, which is alpha plus beta x e power minus x. Right? Because these roots appear here in the exponential. So that's the general solution when omega is 0. When omega is non-zero, then what you have are complex conjugate roots, right? So the corresponding solution yx will be e power minus x alpha times sine omega x beta times cos omega x. Okay, so that solves 9a. Okay, so that solves 9a. Now let's do 9b, which is a 6th order ODE, but it's linear and constant coefficient ODE. So let's do 9b. So 9b, it's y power 6 minus 2y cube plus y equal to 0. Right? So in this case, what you do is that again you write down the characteristic equation, which is m power 6 minus 2m cube plus 1 equal to 0. Right? On this you can observe is actually this is a quadratic equation in m cube. Right? So this is actually m cube minus 1 whole square equal to 0. Right? Or equivalently, now this is a cube minus b cube form. So m minus 1 whole square m square plus m plus 1 whole square equal to 0. So this sixth degree polynomial can be factored like this. So if you solve for this, you have the following roots. So you have m equal to 1 double roots. So 1 1 is a double root here, and then you have, from if you solve here, you will have two roots and both the roots are double roots. So it's minus half plus so the complex roots is minus half plus or minus I root 3 over 2. Okay, and all of these are double roots. So you basically have 1, and then this complex. So you have these three roots, 1 and the complex conjugate roots, and they are all double roots. So you total have 6 roots. So with these, what would be the general solution of this constant coefficient ODE? So 1 is a double root, so alpha 1 plus alpha 2x e power x, double, because it's like a repeated root, and then this complex conjugate is also a double root, so you have exponential of x over 2. Okay, and then alpha 1 alpha 2 is used. Let's use alpha 3 alpha 4 of x sine of root 3x by 2 plus alpha 5 and alpha 6 x cos root 3x by 2 closing. Okay, so this is your general solution for the second problem, 9b. Okay, now let's do 9c. So 9c is a fourth order equation, and what we are given is sin x is a solution of that ODE, right? So it's a fourth order equation. So if you write down the CE corresponding to that fourth order equation, what you get is m power 4 plus 2m cube plus 6m square plus 2m plus 5 equal to 0. Okay, now this is a fourth degree polynomial, right? Now what is given is sine is a solution to this problem. If sine is a solution to this problem, that means the corresponding root that gives you sine as a solution should factor this polynomial, right? So what is the root that gives you sine x, right? Because it's only complex roots gives you sine and cos, right? Sine and cosine, right? So the root, and since there is no exponential here, so power should be 0, so the real part is 0. So the root m equal to plus or minus I for the sine x. So m equal plus or minus I. So the equation corresponding to, so the equation which has these as roots, which is precisely m plus I and m minus I, which is m square plus 1. So this m square plus 1 should factor this, right? If it does not factor this, then the sin x cannot be a solution, because sin x is coming from these roots. So this m square plus 1 should factor this polynomial. So if you factor this polynomial with m square plus 1, you are going to get so that fourth degree polynomial is now basically m square plus 1 of m square. If you factorize it by m square plus 1, this is the polynomial you get. So now you look, now these roots, you know, this is a quadratic equation, you can find out these roots. So the roots of this thing is, second quadratic equation is m equal to minus 1 plus or minus I2, right? So the complex conjugate. So you have two roots from here and you have two roots from here. Total you have 4 roots. It's a fourth it's a fourth degree polynomial. So you have 4 roots. So what are the corresponding, what is the general solution to it? So corresponding to plus or minus I, you get alpha 1 cos x, alpha 2 sin x, plus exponential power minus x, alpha 3 sin 2x, plus alpha 4 cos 2x. Okay, so that is the general solution of this 9c. Okay, now that completes problem number 9. Now let's go to problem number 10. Now problem number 10 is asking you to find the general solution of linear inhomogeneous constant coefficient, right? So here we are asking you to use the method of undetermined coefficients. Okay, and we know, we have done this in the previous assignment exercise also and so on, that if you want to solve an inhomogeneous problem, then the general solution is given as the sum of the complementary function plus the particular integral, right? So basically you solve the homogeneous problem, you have a corresponding and that solution, so the general solution corresponding to the homogeneous problem is called the complementary function, and then you find a particular integral, and finding the particular integral is where you use method of undetermined coefficients and so on. So let's do 10a. So 10a. So in 10a, what is given to you is a fourth order constant coefficient ODE, and then there is a right hand side. Okay. So let's look at the homogeneous problem corresponding to this. So if you look at the homogeneous problem, it will be y power 4 plus 2 y cube, y third derivative 3y double prime equal to the homogeneous problem. So the corresponding characteristic equation will be m power 4 plus 2m cube minus 3m square equal to 0. Right? Now this, if you factorize, it's a fourth order. So if you can actually factorize this as because there is an m square which you can bring out. If you bring out m square, what is left is a quadratic equation, and that quadratic equation can be factorized as m minus 1 and m plus 3 equal to 0. So you have the roots as 1, minus 3 and 0. Okay, and 0 is a repeated root, right? 0 is a repeated root. There are 2 zeros, double root, right? Okay. So what should be the general solution of this, which will be the complementary function of the given equation? General solution of this will be, so there is a double root 0 which gives you alpha 1 and alpha 2x, and then there is a 1 which is alpha 3 e power x plus alpha 4 e power minus 3x. This is your complementary function corresponding to the given ODE. Now you need to find the particular integral, and for that we look at the right hand side, which is given as, so let's call it f of x, the right hand side, right? So f of x is 18x square, okay, plus 16x e power x plus 4 e power 3x minus 9. And what we have seen already is find that annihilator of this, so right, find that differential operator which will kill them. So let's see it cases. So 18 square minus 9 will be seen as 1, 16x, and then 4 e power 3x. Right? And what you will see is that this is a polynomial of degree 2. So d cube will kill this. Okay, and then correspond d cube means you have 0 as a triple root. I mean corresponding because d cube is what, if you multiply the original ODE with this third order differential operator, that will kill this term, right? Now then the second term here, that is again x product, so it's a polynomial multiplied by exponential. Because it's exponential with power e power x, which it is 1, so it's d minus 1. It's a polynomial of degree 1, so it's d minus 1 square. Then there is a 16, so 16 will be the thing, and this will have 1 as a double root. And then the last one here, which will be the annihilator of that, will be 4 times its e power 3x, so it should be d minus 3, which means 3 is a root. Okay, so here if you actually see the first triple root that you get is in addition to, so this root is already appearing in the characteristic equation of the homogeneous equation with a double root there, right? Which means the solution already has up to polynomial x. So now with this triple root, so you are looking for a particular integral yp of x. Now there is already a degree 1, so 3 more, so degree 3, degree, right, degree 2, so degree 1 is already here, 0 is here, 1 is here, 2, 3, 4. So let's look for ax power 4 bx cube plus cx square, because in addition to the double root you have a triple root, so that triple root corresponds to this first 3 terms here which we have written. So a, b, c are parameters to be determined, plus 1 is a double root. 1 is already a root here, single root, and that is corresponding, already appearing here as e power x. So as a double root, it should now appear as d times, right, e power x is already there, so, and double root, so e power x, e power x, x square e power x, so x square e power x plus x e power x, and then there is a root 3. This is not repeating because the root here is minus 3, so you can take directly 3, so it's f times e power 3x. Okay, so this is the yp. So if we determine the parameters a, b, c, d, e, f, then we are done. So what you do, you just differentiate yp, right? So because you want yp to satisfy the given differential equation, right? So you differentiate them up to 4 times, right? You need to substitute that. So you differentiate them up to 4 times and plug it in there and equate the coefficients. So if you differentiate them as many times as you require, and if we equate them, you will get 36 ax square plus 48a 18b x 24a plus 12b minus 6c plus 8d x e power x plus 18d plus 4e e power x plus 108 f e power 3x. This is what you will get on the left hand side, which should be equal to whatever is given on the right hand side. Okay, now you equate the like terms, right? So there is an x squared term here, accumulate all the x squared terms here, and so on. That's what we have done here. So there is x squared term here 18, so minus 36a should be equal to 18, which means a should be minus 1 over 2, right? So we have already written, so if a is minus 1 over 2, so yp of x is minus 1 over 2 x power 4. And then once you have a, then you see this is 0 because there is no x term here. So this is 0, which means b is 48 by in times a, which is minus 24, minus 24 minus 24 by 18, right? Minus 24 by 18 will give you 4 by minus 4 by 3. So b is minus 4 by 3. So that is going to give you, so this term is anyway going to be 0, right? So, and then you have, so you compute b. So b is minus 4 by 3 x cube, okay? And then c. Now to compute c, you equate this. This is the constant term, which probably is equal to minus 9. So if you know what 24 is, minus 12 is then minus 16, which is minus 28, which is minus 28 by 6. Am I right? No, minus 16. Yeah. Yeah. Yeah, so let's say this is 0. Yeah, I'm sorry. So this is equal to, let's do it here, minus half. A is minus half, which means it's minus 12, and then b is minus 4 by 3, so 3 4 minus 16, right, minus 6c equal to minus 9. So that gives you minus 6c is equal to 16 plus 12 is 28. 28 minus 9 is 19. So c is minus 19 over 6. So it's minus 19 over 6 x square. Now d is xex. So d should be 2. So d should be 2. So 2 x square e power x minus what is e? If d is 2, 36, and 36, so e is minus 36 by 4, so which is minus 9, so 9 x e power x, and f, finally f is 108 by 4, right, 108 f equal to 4. So f is 4 by 108, which is 1 over 27 e power 3x. This is the particular integral. So what is your general solution? It's ycx plus ypx. Yp is this entire thing, and yc is something that you already found here. So the sum of these two is that. Okay. Okay. So now let's look at the second problem, which is this. So it's a second order OD. So 10b. Okay. So 10b. So for 10b, if you it's a inhomogeneous equation, so you look at the corresponding homogeneous equation, which is a second order. So it's m square plus 1 equal to 0. So the roots are plus or minus 1, right? So which means the general solution to the homogeneous equation is alpha 1 cos x alpha 2 sin x. Okay. Now you look at the right hand side, what you have is sin x plus 1 minus x square e power x. The annihilator of this sign is d square plus 1. So the corresponding roots are plus or minus I, right? Now for here, this is e power x, so d minus 1 polynomial of degree 2, so cube, and so the roots are 1, 3 repeated roots. 1 is a triple root. One is a triple root. Okay, so here 1 is a triple root is fine, but this root is getting repeated. This root is getting repeated with this root here that is already appearing here. So it's a repeated root. So you're going to look for a particular integral yp of x, right? Which is because it's a repeated root, it's some x times a cos x b sin x plus repeated root 1. So it's c plus dx c d e x square of e power x, which is 1. Okay, so so we need to find a, b, c, d, e. So as usual, now you differentiate this, plug it in the second order differential equation and equate coefficients. So what you will get is some equation like this: 2a sin x plus 2b cos x plus 2c plus 2d plus 2e e power x plus x 2d 4e e power x plus 2e x square e power x, which is sin x plus e power x plus x square e power x. So if you equate coefficients, you immediately see that a is minus half, right, matching this. There is no cos term, so b should be 0, right? And then e power x, so 2c 2d plus 2e is equal to 1. Let's but that we cannot, so let's use this. So 2e is 1, which means e is half. So once you have e, then 2d plus 4e is 0. So it's 2d plus 2 equal to 0. So d is minus 1. And if d is minus 1, and if this is 1, so e is half 1 minus 2. So minus 1, 2c minus 1 2c minus 1 is equal to 1, so c equal to 1. So if you use these a, b from here, what you get is the particular integral, right? So your general solution will be, as we said, alpha 1 cos x, alpha 2 sin x plus yp, which is if you use the values of a, b, c, d, e above, you get minus x cos over 2 plus 1 minus x plus x squared by 2 e power x. So that's your general solution. Okay, we have solved that problem. Okay, now, okay, beautiful. So now let's do the 11th problem. Okay, so 11th problem is, again, we need to find the homogeneous, find the solution, general solution of a linear inhomogeneous problem, but this time they are variable coefficients. Okay, we have spoken constant coefficients. This time we are going to do for variable coefficients. Okay, so 1011a. So we are given the second order ODE, and for x is positive, and we are given that y equal to x is solution of the homogeneous part. Okay, so if you don't have this term here, if it's 0 here, then x is a solution to that problem. Okay, so we will do the same thing. Since we are given one solution, since the second order problem, we will find the linearly independent solution corresponding to that. So let's call y1 of x to be the solution x, of which is the solution of the homogeneous part, right? So now we use the reduction order technique to find the solution y2 of x is x vx. So we have to find a v, right, such that y2 is also a solution of the homogeneous part. So y2, so we need to find a v such that y2 is solution to the homogeneous part of this equation. Okay, so you differentiate y2 as many times as you have there, and you plug it in, then you will have a relation, right? So let's do that. Let's see what is it. X2 of y2 is xv minus x plus 2 of y2 prime is x v prime plus v, okay, plus x square of y2 double prime is x v double prime v prime plus v prime, and that should be equal to 0. Okay, so now you see here there is an x plus 2v, and there is a minus x plus 2v. So this term here and this term here cancels off, right? So what is left is and now here you see minus x square minus x square x plus 2 v prime plus x cube v double prime plus 2x square v prime equal to 0. Okay, and here you see there is a minus x cube v prime minus 2x square v prime x cube v double prime plus 2x square v prime equal to 0. So this 2x square v prime cancels off. What is left with is x cube v double prime minus v prime equal to 0. This should happen for all x, right? And x is greater than 0, which means this is 0, which means what we have is v prime minus v double prime minus v prime is 0, and so if we integrate it, we are going to get that v prime minus v is some constant, and we have seen in the lectures that for this we just choose the constant to be 1, a non-zero constant, right? V prime minus v is some 1. Then if you integrate once more, you are going to get vx to be e power x minus 1, right? Because if you just, so it's log of 1 plus v, derivative of log of 1 plus v, you integrate that, and that's what you get here. Okay, so once you have this, so once you have found v, which means you have found y2. y2 is precisely x times e power x minus x, right? Now this is the linearly independent solution of the homogeneous problem. Now we need to look at the inhomogeneous problem. So we rewrite the inhomogeneous problem in the standard form. So y double prime minus x plus 2 of x y prime plus x plus 2 over x square of y, and that's equal to x, right? So if we use, now we use the method of variation of parameter. In this case, your right hand side is f of x is x, and now you are given y1 and y2 solution of the homogeneous problem. So if you look at the Wronskian of y1 and y2, which is y1 is x, y2 is x e power x minus x, y1 prime is 1, y2 prime is x e power x plus e power x minus 1, right? And that's equal to x square e power x e power x minus x plus x e power x minus x. No, not plus, so it should be minus sign. Yeah, these two are opposite sign, right? Was minus of that, right? Minus x e power x plus x. So this x e power x minus x e power x minus x plus x gives you Wronskian to be x squared e power x. So now in the lectures we have computed the formula for v1 and v2, right? So because in the method of variation of parameter, what do we know? We look for a particular integrals v1 and v2 such that v1 of y1 and v2 of y2 is a solution, right? So the formula for v1 is minus integral y2 f over Wronskian dx. So here everything else is known, y2 is known, y2 is here, right? F is known, f is x here, so it's x square something and divided by this, so it's basically integral of minus integral of x times, so x square e power x minus x square by x square e power x, which is integral of 1 over e power x minus 1. Right? So So if you integrate that, what you're going to get is minus x power minus e power minus x. Right? Now similarly, if you do for v2 of x, it will be integral y1 f over Wronskian. Okay, integral y1 is something that you know, y1 was x, right? y1 is x and f is x, so x square by x square e power x, which is the integral of 1 over e power x. So this, if you integrate, is precisely minus e power minus x. So if this is your v1 v2, we know yp is v1 y1, v1 is minus x minus e power x times y1, which is x, right? And then plus v2 y2, but v2 is minus e power minus x, y2 is precisely x e power x minus x, x e power x minus x. So that's going to give you minus x square minus x e power minus x minus x plus x e power minus x. So this and this cancels off. What is left is minus x square minus x. Okay, so if this is your yp, what is your general solution? Yc plus yp. And what is your yc? Okay, I didn't write it, but anyway, we know these two solutions, right? So it's a linear combination of that. So it's, say, alpha 1x plus alpha 2 x e power x minus x minus x square minus x. Alright, so here you can actually see there is an x here, there is an x here, so this can be combined together to write as new alpha 1x plus x alpha 2 e power x minus x square minus x. Okay, so that's the general solution. Okay. Okay, what we have done is that this scalar minus x and this is a new scalar. So this alpha 1 minus alpha 2 is a new scalar. So that can be thought of as a new scalar alpha 1. Okay, so basically it should be a linear, it should be a linear combination of linearly independent functions, right? Okay, so that kind of solves 10a, right? Now let's do 10a, right? Yeah, now let's do 10b. This problem in the real line. 10, sorry, not 10b, 11b. 11a we did 11a. Now let's do 11b. So 11b. Okay, so what is given is x square y double prime plus xy prime plus 4y 2x log x in the positive real line. So now you see it is already in the form, it is in the Cauchy-Euler form, right? Because all the coefficients are this powers of x. So if you introduce this new variable, s is log ns, right? That's what you do for Cauchy-Euler form. Then what you know is that e power s is your x, right? So what is y? What is x dy? What is xy prime? So now s, so we have to write y as dy by dx. So dy by ds can be thought of as dy dx dx ds. So dy by ds is y prime times, so in this case prime is depending on the prime is the derivative with respect to the x variable, dx by ds is dx by ds is e power s, which is x, right? Similarly, what is x square of y double prime, right? The way we have here, if you do that, which will be precisely, we have done this in the lectures, right? So this, so if you use this substitution in the equation, then this variable coefficient ODE becomes a constant coefficient ODE in the y and s variable, and the right hand side, which is x log x, will become now 2s e power s. So now there is a linear ODE in the y and s variable. So look at with a inhomogeneous. So it's an inhomogeneous linear constant coefficient. You know how to solve it. So look at the characteristic equation of that, which will be m square plus 4 equal to 0. So the roots are plus or minus I2, which means the complementary function that you are looking for which is now a function of s, will be alpha 1 sine 2s plus alpha 2 cos 2s, right? So that's the complementary function. Now we have to find the particular integral. We will use the method of undetermined coefficient. So the right hand side is, this is your f of s, let's say, right? Now if you look at right hand side, the annihilator of that is precisely d minus 1 whole square, right? And the corresponding roots of this is 1 is the double root, that is the repeated root, right? 1 is the double root, and 1 is not a root there as anyway, right? So you can look for a particular integral as 1 double root as as e power s b e power s, right? Now if you differentiate this, now this has to satisfy this OD in the s variable, right? So if this has to satisfy that, you differentiate that and equate and substitute, plug it in and equate like coefficient. So if you differentiate and substitute in, you are going to get this equation, okay? If you equate coefficients, you are going to get a and b, right? Because 5a is 2, so a is 2 by 5, so your yp of s is 2 by 5 s e power s, and your b will be 4 over 25 e power s, right? So That's going to give you the general solution in the s variable, which is alpha 1 sine 2s here, right? This complementary function plus this particular integral is going to give you alpha 2 cos 2s 2 over 5 s e power s 4 over 25 e power s. Now we want a solution in terms of the x variable. So wherever you have s, you put in log x. So alpha 1 sine log x 2s, right? So log x square plus alpha 2 cos log x square plus x log x square by 5 minus 4x by 25, and that's your general solution for this problem. Okay, so with this we have completed assignment number 11. We'll see you in the next assignment. Thanks a lot. Bye.